Hello, this is the fourth video that I am preparing for the revised simplex method. This format that I'm using is very familiar for those of you who have looked at the previous videos. In here I have defined an LP in which the A matrix is defined. There are 4 constraints, 6 variables. The right hand side vector is defined, the values are identified, and all these are in the form of less than or equal sign. So AX less than or equal B, adding the slack variables, a 4x4 identity matrix, and also the coefficient of the objective function, which is a maximization problem, is given as C. We will start the problem, and the set of basic variables consists of the slack variables. The 4 slack variables will be our basic variables. Of course the matrix B will be the identity matrix associated with S1, S2, S3, and S4, and CB is going to be 0, 0, 0, 0, as slack variables do not exist in the objective function. Based on what we have learned from the structure of the tableau, we are going to do the required calculations. B inverse is calculated, which is of course in this case is the identity matrix. B inverse A, B inverse B is calculated. CBB inverse and CBB inverse A minus C are calculated. Don't forget that these 2 values represent the optimality conditions, and B inverse B represents the feasibility conditions. As we follow the regular simplex algorithm, the right hand side is kept positive in each iteration, and we will search for optimality. In these values, the most negative number is selected as the entering variable. Because there are some negative numbers in here, this basis is not optimal. Therefore we select the most negative number in here, which is -6, which is associated with the 1, 2, 3, 4, 5, 6. That is X5 column. An X5 column in the B inverse A, the pivot column, will be these numbers. That's the right hand side. This is the pivot column. We are going to calculate the min ratio to identify the leaving variable. The min ratio has been calculated here. The min ratio happens to be on the 3rd row, and the 3rd row is associated with the S3 in this basis. Therefore X5 enters the basis and S3 leaves the basis. We now form our new basis based on this condition. The adjacent extreme point is represented in here. Again, we have our basic calculations, but now for our calculation, the new basis consists of S1, S2, X5, which replaced S3 and S4. So in my B, the only column associated with X5 is going to replace the other one. The X5 column, P5, 1, 1, 2, 0, is going to replace the variable which was here, is now X5, so these numbers are here. And again, associated with that, at the same location, I'm going to change that value with the coefficient of X5 in the objective function. Again, we are going to do the calculations, and in this calculation, B inverse B inverse A, B inverse B, CBB inverse A, and CBB inverse have also been calculated, and these values again represent the optimality condition. We are going to check them to see whether there is a negative number in this set, and there are a couple of negative numbers. We will select the most negative value as the entering variable, and its associated column in here in B inverse A will be the pivot column. The right hand side has been calculated, so I'm going to calculate the mean ratio. Just because this one is negative, I'm not going to calculate this one, but for the first, second, and the fourth one, I will be calculating the mean ratio. The mean ratio in this case has been calculated. It belongs to second row, and second row is S2. So S2 is going to leave, and X3 is going to enter the basis. So we go to the next set of calculations, and in here we will also basically have the same things that we had before, the same type of calculations, except that this time our XB consists of S1, X3, which replaced S2, X5, and S4, and the column of X3 from P3 has been copied down here. The values of CB are also written in here, and the new coefficient for this second variable in the basis 4 is coming from here, X1, X2, X3, and that is 4X3. Again, we will do the calculation required for this step. We will calculate the CBB inverse, and we will calculate the CBB inverse A minus C, which are representing the optimality condition. As we notice, there is one negative number in here. That's the only negative number in here. Therefore, this variable, which is representing the X2 variable, is going to enter the basis. To identify the leaving variable, we need to do the calculations for minimum ratio. As we perform the calculation for the minimum ratio, and as we perform these calculations, the minimum ratio happens to be at the first row, which is associated with S1. So this is going to be our leaving variable. So our leaving variable S1, that is our entering variable X2. Therefore X2 is going to enter the basis, and S1 is going to leave the basis. We will perform another iteration. We are going to identify the new basis, which now X2 is replacing S1. The matrix B has been identified, and again it is X2, X3, and X5, and S4. That is S4, this is X5, this is X3, and this is X2, as you can be seen in here, 3, 0, 1, 2. So B is formed associated with this. Associated with that, we will form the CB is identified, and CB is identified. We can now perform the regular calculation. And as we look at these two sets of numbers, CBB inverse and CBB inverse A minus C, we do not see any negative number. Therefore, optimality condition is satisfied. So for the optimal solution, X1, X4, and X6 are not in the basis, so they are non-basic and equals 0. X2 is 8 and 12 13th. X3 is 11 and 5 13th. X5 is 13 and 3/13, and the value of z that we have calculated is 169 and 7/13, and that is the solution to this problem. Now notice that in this problem and all the steps that we followed, when we looked at the CBB inverse and CBB inverse A minus C, the optimality condition, all the negative numbers happen to be in here, and that might give the impression that it is always the case in here. That is not the case. Sometimes these values are going to be negative as well, so we need to take a look at those. The other thing is that as you look at some of these numbers, you will see 0 with the minus sign in front of it. These are round-off calculations that we have. These values are actually 0, so there is no negative number in here. So let's take a look at another example in which we will have some negative numbers in here that are going to be exchanged with the variables in the basis. Here's the other example. I have selected the same size problem. The numbers are a little bit different, and as we go through this problem, the first step, again, the same set that we had, S1, S2, S3, and S4, and when we do the calculations for this first tableau, we will notice that entering variable is this variable x4. X4 is the entering variable, and when we do the calculation for mean ratio, the leaving variable is going to be S4. So X4 enters and S4 leaves. In the next tableau, based on the new basis, when we do the calculations, we will notice that in our optimality conditions, the most negative numbers happen to be in here, which belongs to x5. x5 becomes our entering variable, and we perform calculations for mean ratio, and the second row, the variable of the second row, which is s2, is going to be the leaving variable. So x5 enters and s2 leaves. So we set up the new basis, and based on this value of the new basis, which is now s1, x5, s3, and x4, we are going to perform the calculations. And as we perform the calculations in here, we will notice that the entering variable in this case, the most negative number in this case, is this value. However, notice that there is a negative number under CBB inverse 2, but because this is more negative, we will select this value to enter the basis, and that is associated with x2. To identify what the leaving variable is, we need to perform the mean ratio, and based on the mean ratio, we realize that the first row variable is the one that is going to leave the basis. As it is leaving the basis, we are forming our new basis. We are forming our new basis. This new basis now is x2, x5, s3, and x4. Based on that, we will set the b, we will set the cb, and perform the operation. We will also calculate the values of CBB inverse and CBB inverse A minus C. Now, again, there is a negative number in here, but there is a more negative number in here under x6. That is the x6. So x6, the pivot column in here, and then we will do the calculations for the min ratio. We will calculate the min ratio. The min happens to be at this point. At this point, the min happens to be at this point. Again, remember, this is not really a negative 0. This is just 0. It's the round-off calculation, the way that is performed in here. So in this case, x6 enters, and the variable in here, one before the last in our basis, is going to leave. One before the last is s3 variable. So s3 is going to leave, and x6 is going to enter the basis. In this iteration, I have x2, x5, x6, and x4. x6 replaced s3 that was in this location. CBB inverse is calculated. CBB inverse A minus C is calculated. Now notice that there is no negative number in here. There are actually two negative numbers in here, and this is the more negative value. Therefore, this, which belongs to the S1 column, is the entering variable. Again, we will perform our min ratio, but this time this is the pivot column. As we will perform the min ratio is going to be in here, and that is the first row, and the first row in our problem is x2. So x2, that as in one of the steps entered into the problem, is now going to leave the basis. S1 will enter into the basis, and x2 will leave the basis. We are going to create our new set of calculations, perform the revised simplex iteration. The new xb is going to be s1, x5, x6, and x4. Based on that, b is formed, cb is formed, calculations are performed, optimality conditions are calculated, CBB inverse A minus C and CBB inverse are calculated. There is no negative number in here, but there is a negative number in here, and this is associated with S2. Under the B inverse, this is associated with the S2, and this is going to be our pivot column. So we will do the calculations for the right hand side, and these values are calculated, and we are going to do the mean ratio calculations, and there's only one that can be calculated, and that is associated with the last one. Remember, all these three numbers are negative, and it was only the last one that could do that, and last one corresponds to x4. So x4 is going to leave the basis, and s2 is going to enter the basis. So we will form the new basis based on s4 replacing x4. As we do that and create the new basis of s1, x5, x6, and s2, perform the calculations for B inverse A, CBB inverse A minus C. We notice that there is no negative number in this set. Therefore, this solution is the optimal solution for the problem. And to perform the calculations for their values and the value of z, we will calculate B inverse B, which is going to be these values, and the z value is also calculated. The solution for us, because x1, x2, x3, and x4 are not in the basis, they are all going to be non-basic and 0. x5 value is 22, x6 value is 24. Remember what these things were, and the only main variables that were here were x5 and x6. These two were slack variables. The value of z calculated to be 160.